Hello everyone. In continuation of the previous videos, which was on consolidation process, last time we have seen that if the ground is subjected to any vertical loading, this intensity of loading is going to create an extra pore water pressure on saturated clay. Let's say this is the saturated clay, and it is having sand both at the top and its bottom, then it will have double drainage. If it is fully saturated, any extra loading will increase the pore water pressure, and the extra pore water pressure will get developed in the soil, which will dissipate. Now, there is going to have two-way drainage because the extra pore water can drain off either at the top or at the bottom. So you will have two-way drainage. You can see before application of this intensity of loading, this saturated clay has got certain overburden. So when there is no loading, before loading, this is the condition, and this condition, say this saturated clay, here you can calculate the overburden pressure at any level. So by knowing the vertical distance from the ground level and knowing the unit weight of the ground or the soil mass, you can calculate the overburden pressure. So what is the overburden pressure here? You can find out the effective overburden pressure. So this is the effective overburden pressure. Overburden. That means due to self weight of the soil mass, what is the effective overburden pressure? At any point P, you can find it out. But the moment you apply the intensity of loading, this point P will have now increase in pore water pressure. And once this pore water pressure dissipates, the total pressure at this point P will be effective overburden pressure plus, due to this loading, post-loading, upon dissipation of the excess pore water pressure, this effective overburden pressure will increase by, this is the increase in the loading. So because of this intensity of loading at this point P, you have got effective overburden pressure due to the self weight plus due to this intensity of loading after dissipation of the pore water pressure. Finally, you get the increase in pressure. So increase in pressure is delta sigma prime, and the total intensity of pressure is this. And therefore, if you want to find out the value of Cc for normally consolidated soil, last time I have shown that this is going to be the change in void ratio. That is, the change in void ratio means before application of this intensity of loading, extra loading, what is the original? So the original or initial overburden pressure, that minus what is the after application of this loading, when the pore water pressure dissipates, what is the void ratio? So this difference, this final void ratio, so here it becomes the final void ratio from original or initial overburden. It is the final after application of this intensity of loading, and the difference of the two will give you the delta E, the decrease in void ratio, divided by log of sigma naught prime plus delta sigma prime, that is the intensity of this loading at any point, divided by the effective overburden pressure to the base 10. So this you can find it out. And from the one-dimensional consolidation test also, you can calculate this by applying a particular effective overburden pressure, and you can calculate this particular value for a different pressure range. So if you calculate the value of Cc for different pressure range, this you can calculate it. The change in void ratio log of sigma 2 prime upon sigma 1 prime to the base 10. So the pressure is increased in one-dimensional consolidation test from sigma 1 to sigma 2 prime, and you get, when you plot it on a semi-log paper, the void ratio versus this effective pressure is going to be a straight line, and this slope of this line will give you delta E divided by log of this one, sigma 1 prime and sigma 2 prime. So you can find it out from this. Also, from empirical relationship also we can find it out, the value of Cc. So the empirical relationship way back in 1944, Skempton gave a very simplistic empirical relationship for calculating the compression index Cc, and this compression index Cc is given by 0.009 liquid limit in percentage minus 10. So that was given by Skempton. So Skempton, way back in 1944, he gave this simple, this one. So you can collect the undisturbed sample and from the ground and find out the liquid limit and find out the value of Cc. Also, later on, in the year 1985, Nagaraj and Murthy of Indian Institute of Science, Bangalore, they gave a very simple relationship where Cc can be calculated as 0.2343 into liquid limit in percent divided by 100 into specific gravity. So this is a very simple relationship that can be used to calculate the value of Cc. Say, for example, let's say the liquid limit doesn't take much time. When you perform the test in the laboratory, liquid limit, you can find it out. A very simple Casagrande liquid limit apparatus you can make use of. Let's say for any clay soil, the liquid limit is say 35%. For example, it's 35%. If you use 1, then From 1, the value of compression index will be 0.009 LL 35 minus 10, that is going to be 25. And if you calculate it, you can find out the value very easily. 0.009 multiplied by 25, you get 0.225. So this is the value of Cc. Normally for inorganic clay, you get this kind of value. And if you make use of the expression 2, then it becomes 0. We can calculate it. In fact, 0.2343 into liquid limit is 35%. So divided by 100 is 0.35 multiplied by GS for inorganic clay is 2.7. So into 2.7, this is 0.2214. So for LL equal to 35%, from Nagaraj and Murthy empirical relationship, the value of Cc comes out to be 0.221. So almost similar values you are going to get it. So you can calculate very easily the value of Cc by performing one-dimensional consolidation test, or by from the empirical relationship. So these last time I have talked about coefficient of compressibility, AV. I have talked about coefficient of volume compressibility, MV. These all can be used, these all coefficients can be used for calculating the consolidation settlement. So finally, our objective is how to find out the consolidation settlement. So let's see how to find out the consolidation settlement. So the consolidation settlement for normally consolidated clay and over consolidated clay, last time I have talked in the previous video what is normally consolidated clay and what is over consolidated or pre-consolidated clay. So let's concentrate on Cc because for normally consolidated NC clay, the value of consolidation settlement under any given intensity of pressure, Sc, is given as this compression index divided by 1 plus E naught into height of the clay layer, thickness of the clay layer H, into log of sigma naught prime, that is overburden pressure, plus increase in pressure divided by overburden pressure to the base 10. This is the standard expression that you should remember it. So if this is the ground where this is NC clay, normally consolidated clay, and let's say it is having upper layer of sand, and also you are having sandy layer below this. So it is sandwiched between two sandy layers, top and bottom, and it is fully saturated. So effective overburden pressure, as I told you, you can find out for the thickness of this one. Let's say the thickness of this clay layer is H. You can find out the overburden pressure. So effective overburden pressure you can calculate. Cc, you can have empirical relationship or from one dimensional consolidation. And the original void ratio also, you can find it out. And H is the height of the clay layer. So you can substitute it here. And when you apply the additional pressure in the form of any structure, so that a structural load is transferred through the footing, or if you put any surcharge over here, you are going to put additional loading, and this additional loading is going to create the additional pressure, and that additional pressure due to this loading is called delta sigma prime. So this delta sigma prime you can calculate by knowing Bouwsnik stress distribution theory. And in shallow foundation, I have already shown you how by approximate technique, approximate method, you can calculate this delta sigma prime. And therefore, you can find out the consolidation settlement using CC value very easily. So consolidation settlement, this for normally consolidated clay. That means the present overburden pressure is highest. So the soil has not been subjected to a pressure greater than the present pressure. So in that case, this is called normally consolidated clay. Now, if it is over consolidated clay or pre-consolidated clay, that means the soil has been subjected to higher pressure than the present pressure. So that you have seen how to find out pre-consolidation pressure. So if it is over consolidated, so for consolidation settlement for over consolidated or pre-consolidated, clay. So the ground has been subjected to higher pressure than the present pressure in the past due to any reason which I have explained to you in the previous video. Now here for OC clay, you know that when you are going to plot it, here the void ratio, and on a semi-log paper it's going to be this. On logarithmic scale, the nature is going to be like this. So here you know that it becomes curvilinear. That means up to certain range there is going to be pre-consolidation, and you can find out always the pre-consolidation pressure. So pre-consolidation pressure, the technique of finding out is already known to you. So if the over consolidation soil, if you find that the overburden pressure on effective overburden pressure plus this increase in pressure due to the external loading is less than equal to sigma p prime. That means it is up to this zone. The ground we are considering here, the clay is sandwiched between two say sandy layer. Now this clay has been subjected to higher pressure in the past. So pre-consolidation pressure, you know it, that it has been subjected to, and the present overburden pressure plus due to the external loading, additional loading, this increase in pressure is less than equal to the pre-consolidated pressure. Then I have already told you that if it is pre-consolidated clay, you should find out the coefficient of recompression index. So it is called recompression index, CR. CC is called compression index, or CR is called recompression index. Make use of recompression index so that SC can be calculated very easily. So in that case, it is very simple that SC equal to CR. Now here, because it is less than sigma P prime, you should not use CC, you should use CR, and CR is going to be 7 to 12% of CC, very less value, divided by 1 plus E naught into the thickness H of the clay soil mass into log of sigma naught prime plus delta sigma prime divided by sigma naught prime to the base 10. So here Cc must be replaced by Cr if sigma naught prime plus delta sigma prime is less than equal to sigma P prime, where sigma P prime is called pre-consolidation pressure or over-consolidation, pre-consolidation pressure. So this expression is very important. One should remember it if it is over consolidated clay. Now, the condition could be that this effective overburden pressure, the present pressure is effective overburden pressure is less than pre-consolidation pressure. Already in the past, this ground has been subjected to due to glacier or due to any structure which is not existing today, but in the past it has been subjected to higher pressure. So the present overburden pressure is less than the past pressure, pre-consolidation pressure, but the pre-consolidation pressure is less than sigma naught prime plus delta sigma prime. Now when you apply the additional loading, this sigma P prime is less than this. Then in this case, if this is the case, how will you find out the value of SC? That's very important. So you see, for this case, the consolidation settlement will be equal to CR divided by 1 plus E naught multiplied by H, where H is the thickness as shown in the diagram, into log of sigma P prime, pre-consolidation pressure, divided by effective overburden pressure to the base 10 plus. Now, this pressure exceeds the pre-consolidation pressure, sigma naught prime plus delta sigma. So now you will have to use Cc. So Cc divided by 1 plus E naught here into H multiplied by log of sigma naught prime plus delta sigma prime divided by sigma P prime to the base 10. Very, very important, these two expressions. You should keep it in mind for solving any problem. So for solving the consolidation settlement, we need to know this. Now, invariably we use CC, CR value, and in order to compute this consolidation settlement. However, last time I have told you that MB can also be used to calculate the consolidation settlement. So, some of the problems we will be doing in the next video to compute the consolidation settlement using uh, CC, using CR, using MB. So, MB, of course, is for different pressure range, because the variation of MB is going to be like this. So, as the pressure range is going to increase, change, the value of MB is also going to change. So, it is for, it doesn't have a unique value like CC, whereas CC you can see it's a straight line. So, we can make use of both MV and CC, CR in order to calculate, as the ground condition maybe, we can calculate the consolidation settlement. So, in the next video, we will be calculating the consolidation settlement, and that will make your point crystal clear. Thank you very much.